Okay, in this video, we're going to find the total capacitance or the equivalent capacitance for capacitors that are connected in series and in parallel. So if you remember how to find the equivalent resistance for resistors connected in series and parallel, then you can figure out how to do the capacitance. It's just opposite of the resistance. So for this first circuit here, we have three capacitors connected in parallel. And in order to find the total capacitance for this circuit, we just need to add C1, C2, and C3 together. So this is pretty easy for a parallel circuit. We just have C1 plus C2 plus C3. So in series, it's a little bit more complicated for a capacitor. So we have series circuit over here. These are just three capacitors connected next to each other. So for capacitors connected in series, the equation that we have to use to find the total capacitance is 1 over C total is equal to 1 over C1 plus 1 over C2 plus 1 over C3. Of course, if you have a different amount of capacitors, like 4 or 2, it would just be 1 over C1 plus 1 over C2, or if there's more, you just keep adding 1 over that capacitance. We have the inverse of the total capacitance in this equation. So what we have to do is actually take the inverse of both sides in order to get C total. So when we talk about taking the inverse of something, that's just switching what's in the numerator and denominator. So for what we have on the left here, we're just switching C total and putting it over 1. But of course, if we have something over 1, we don't keep the over 1 part in the equation. So we've taken the inverse of the left side. Now we want to take the inverse of the right side. So in order to put this into an equation before you have the actual values, you would just put 1 over C1 plus 1 over C2 plus 1 over C3. And this just means you take the inverse of that whole value. So once you have 1 over C1, you add that to 1 over C2, and then you add that to 1 over C3, and then you take the inverse of that number. And of course, when we have resistors in series and parallel, we do the exact opposite. For parallel resistors, we do 1 over R total equals 1 over R1, and so on. And then for resistors connected in series, we just add those together. So it's the exact opposite of how you find the total capacitance. So let's go ahead and do some examples with these three capacitances that we have over here. So C1 is 0.50 microfarads. C2 is 10 microfarads, and C3 is 20 microfarads. So microfarads is, of course, just 10 to the negative 6 farads. So it's just a very small number. And since these equations only have capacitances in them, we don't actually need to convert this to farads and put in the 10 to the negative 6. We can just leave it as microfarads, and then our answer will also be in microfarads. So let's go ahead and do that. So very easy for the parallel circuit. We just have C total is equal to 0.50 microfarads plus 10 microfarads plus 20 microfarads. And that gives us C total is equal to 30.5 microfarads. Now we'll go ahead and do the example for the capacitors in series. So let's try to make some room. Okay, so we just want to plug in what we have. So 1 over 0.50 microfarads plus 1 over 10 microfarads plus 1 over 20 microfarads. And we take the inverse of all of that once we find it. So you can put this into a calculator as it is. So you would just put parentheses, additional parentheses around each of these, and then add them together, and then the whole thing in its own parentheses to the -1 power. You can do it that way, or you can do them separately and add them together. But what you should get is 0.47 microfarads for the answer. So when you have capacitors in series, the number when you add them together is actually going to be, or when you find the total capacitance, is going to be a lot smaller than the individual capacitors. Whereas when you have them connected in parallel, the total is obviously going to be much bigger than any of the individual capacitors because you're just adding them together as they are. So hopefully that was helpful. Let me know in the comments if you have any questions, and thanks for watching.